Alright, this is part 4 of our lesson on polynomials. In this video we will focus on analyzing functions and getting down into the details of the characteristics of polynomial functions. So we'll talk about maxima, minima, zeros, y-intercepts, in behavior, and intervals of increasing and intervals of decreasing. So these last two problems are all about the characteristics of a polynomial function. Alright, absolute maxima. Well, there really can only be one, so absolute maximum. Is there an absolute maximum? An absolute maximum would be the highest point on this graph, none higher. And because this graph goes up forever, there is no absolute maximum. Okay, so absolute maximum, none. Alright, what about relative or local maxima? Okay, is there a top of a hill happening somewhere? Yeah, like right here is the top of a hill. Now this seems to be a little bit off from being exactly at, this is something very close to 1, 6. Okay, so if you put 1, 6, I'm going to totally accept that. But you know, if you put something like 0.9, 6 or something like that, I'll accept that also. Okay, I'm just going to put 1, 6. Now, absolute minima. Well, there would only be one, even if there was one. Absolute minimum. That would be the lowest point on the graph. But again, since this graph, alright, this is bugging me. Since the graph goes forever, let me just deal with my OCD here for a second. Okay, this graph goes down forever, so there will be no absolute minimum. Okay, so absolute minimum, none. There is none. What about relative minima? Okay, do you see any points that are at the bottom of a valley, even if it's not the lowest point on the graph? Yeah, here's one right here. Now this is definitely between the lines. So let's call this negative 1.5 comma negative 1, right? Alright, something very close to that. Alright, but this is the relative minimum. Okay, so that's about negative 1.5 comma negative 1. Are there any zeros? Okay, the zeros are at the x-intercepts of a graph. So technically the zeros are just the numbers, not the with parentheses. Okay, that's the subtle difference between x-intercepts and zeros. For example, I'm going to do the zeros in green. So there's a zero here, and there's another one here, and there's another one here. Now, if I said x-intercept, the x-intercept would be 2, 0. Alright, that's an x-intercept. Okay? Now, on the other hand, if I say 0, okay, the 0 is just 2. 2 is the 0. So just the number is the 0. The whole ordered pair is the x-intercept. Okay, so technically if I want the zeros are 2, negative 1, and negative 2. We'll pull up little boxes around them so they stand out. Okay, these are the zeros of the function. Negative 2, negative 1, and 2. Okay, without the comma 0 part. So what did I say? Negative 2, negative 1, and 2. Now I definitely did not emphasize the difference between zeros and x-intercepts in class because I don't think it's that important. So if you put negative 2, 0, you know, I'm not going to mark that wrong or anything. Okay, y-intercept. Now we're talking intercepts. Okay, an intercept is the whole ordered pair. So the y-intercept is right here. Okay, so the y-intercept is 0, 4. Alright, the whole thing. That's the y-intercept. Okay, and that should be as an ordered pair, not just a number. Now, end behavior. Okay, so this is saying what's happening on the left, and this is asking what happens as we go to the right. Okay, and the question is, does it rise or fall? Because that's going to determine what I put here. So looking at this graph, on the left, okay, it rises. Okay, on the right, it falls. Okay, so on the left it rises, so that's why I'm going to put positive infinity. Okay, on the left it rises. On the right it was falling, so that's negative infinity. So positive infinity, negative infinity for that end behavior. Okay, now intervals of increasing and intervals of decreasing. Okay, these are always x values. Okay, let me emphasize that to you. Intervals of increasing and intervals of decreasing, it's sort of like the domain. It's always the x value. So only look at the x-axis when you answer this question. Okay, so intervals of increasing, I feel like I need to erase this junk. When you're talking about increasing and decreasing, you need to look at the graph from left to right. Now, as I travel from left to right, if I were to travel along this path, for this part of the path, I would be falling. So this will give me my first decreasing interval. Okay, and it came from a kind of infinity, so we'll talk about that in a moment. But then starting off here, then I will begin going uphill, uphill, uphill. So this is going to give me my increasing interval. And then I'm back to downhill again. Okay, so from here on, I am going downhill. Okay? So we have one increasing interval and two decreasing intervals. Okay, so now remember we are talking about x values, so let's go ahead and talk about our one increasing interval first. So our increasing interval, if we look only at the x-axis, alright, it starts right here. Okay, this is where the increasing interval starts, and it stops right here. Okay, because I'm looking up and I'm seeing where it stops. Okay, but just looking at the x-axis, alright, looking at the x values, it goes from here to here. Now these marks make it a little bit hard to see, so I'm going to take them away for a second. But so just remember, it was like this. Alright, so this, about like this is my increasing interval if I look at the x values. So that seems to be like negative 1.5 to something close to 1. Okay, so we're just doing the x values. So the increasing interval is going to be like this. Negative 1.5 to close to 1. Now you could put like 0.9 if you want to, or something like that. But if you just put 1, I'm going to definitely accept that because it's super close. Alright, now increasing and decreasing intervals always get round parentheses to show that we're not including the endpoints. Alright, and that's because right at the end, right here at the bottom, it's neither increasing nor decreasing. It's like right at the point where it switches from one to the other. Same thing up here, right at the top, it's neither increasing nor decreasing. It's a moment of flatness. So don't include the endpoint. Use round parentheses. Okay, took away too much. All right, now let's talk about intervals of decreasing. Now the decreasing intervals, okay, are these ones I've shown here in pink. So let me get rid of that. Okay, so now you can see the sort of cutoff here as far as the decreasing interval. Alright, let me use my highlighting again if I can. Now you can see that this is the end of my decreasing interval right here, because here's where it switches. Remember, I'm only looking at the x-axis. Okay, now if I want to see how far does the decreasing interval go to the left, well, this goes to negative infinity. Ignore the fact that it's going up, okay, because that just depends on if you look at it this way, but ignore the upward pointing arrow. It's also leaning to the left. So you just need to understand that as far as how far it goes to the left, this goes to the left forever. So this decreasing interval goes from negative infinity, okay, because that's the kind of infinity that you find out here on the left. Okay, it goes from negative infinity to here, which was about negative 1.5. So negative infinity to negative 1.5, that's the decreasing interval, the first one. Okay, so negative infinity to negative 1.5, always round parentheses. Okay, but there was another decreasing interval, alright, this other pink part, the part that goes from here to here, and of course this is going forever. But as far as x values go, okay, this interval is starting out right here. Okay, this is the point where the decreasing interval starts. But this is what? It's about 1,6. But all we care about is the x value. Okay, all we care about is the x value. So we're looking at the 1. And then how far does that go to the right? Okay, well, it starts here, but it goes to the right forever. So we'll call this 1 to infinity. Alright, positive infinity, because that's the kind of infinity that you get on the right. Okay, so our other increasing interval is going to be from about 1 to infinity. Now if I look at it carefully, it looks like a little bit maybe short of 1, maybe 0.9, 0.8. So if you said something like 0.8 to infinity, that'll work too. Okay, but that's it for increasing and decreasing intervals. And in fact, I think, oh no, there's one more. Okay, this video is getting long, but there's only one problem left, so we're just going to have to deal with it and let it be a long video. Okay, so absolute maxima. Alright, does this graph have a highest point? No, it does not, because this graph goes forever up on the left and the right. So absolute maxima, no, there are none. What about local or relative maxima? Okay, do you see something that's maybe the top of a hill? Yeah, right here. There's a relative maximum, -1, 0. Okay, -1, 0. What about absolute minima? Alright, is there a lowest point of the graph, a 100% lowest point? Yeah, right here. This is the lowest point of the graph, and it does not go any lower than this. So 0.4, -2.8. Okay, so 0.4, -2.8. Alright, what about relative minima? Alright, do you see a point that's not the lowest, but it is at the bottom of a valley? Well, I'm talking about this point right here. This is at the bottom of a little valley, even though it is not the absolute lowest point on the graph. So this would be a relative minimum or a local minimum. So that's negative 1.7, negative 0.4. Okay, what else we got? Zeros. Alright, zeros are like x-intercepts, except for they're only the x values. Okay, so we have a 0 here at negative 2, and we have a 0 here at negative 1, and we have a 0 here at positive 1. So negative 2, negative 1, positive 1. Alright, technically the zeros are just the numbers. Negative 2, negative 1, positive 1. Now if you put negative 2 comma 0, what you put was the x-intercept, which is very similar, but technically the zeros are just the numbers. Okay, I'm not going to mark it wrong if you put like 1 comma 0 instead of just 1. Now the y-intercept is an ordered pair. Okay, and I can already see the y-intercept right there. Okay, the y-intercept is the point where the graph touches the y-axis. So that's 0 comma negative 2 is the y-intercept. Now the end behavior. What happens on the left? Maybe I'll write that down. What happens on the left and what happens on the right? Well, let's take a look. Now for polynomials, we're talking about is it rising or falling. And as we go to the left, you can see that the graph is rising on the left. As we go to the right, you can see that the graph is rising again. So it's rising on the left and it's rising on the right. So that's going to be positive infinity and positive infinity. Okay, so positive infinity, positive infinity. Alright, it's time to talk about intervals of increasing and intervals of decreasing. Probably the most important thing for you to keep in mind is when we're talking about intervals of increasing and decreasing, we are only talking about x values. Alright, it's a lot like domain. We will only be looking at the x-axis. Alright, so the idea is we are going to be traveling from left to right across this graph. Okay, so that means we're starting here from negative infinity and we're going to end up at positive infinity. Okay, so starting in from negative infinity, as we travel along the curve like this, for the first part of the journey we are falling. Okay, so that is a decreasing interval. Alright, so like I said, we're coming in from the far left here, so this is going to be from negative infinity to this point right here, but all we care about is the x value. Alright, we're looking at the x-axis right now. So we will say from our first decreasing interval, because we're going downhill, is from negative infinity to negative 1.7. Okay, decreasing interval. Alright, so negative infinity to negative 1.7. These intervals always get round parentheses to show that we are not including the endpoints, because right here at negative 1.7 we're right at the bottom of this valley. We're neither increasing nor decreasing, we're just sitting at the bottom. Alright, but then our story continues and we start going uphill. So this next part of the journey is an increasing part of the journey. So from there to there is increasing. And again, we're only interested in the x values when we say from where to where. So we're talking about from negative 1.7 to negative 1 is our first increasing interval. Negative 1.7 to negative 1. Maybe I'll put negative 1.0 just for fun. Okay, let's see what happens next in our journey. Alright, well, it looks like we're about to take another big drop downhill. So, once again, this is a decreasing interval. Okay? And once again, when we talk about intervals, we are talking about x values. So yes, from here to here is decreasing. But what are the x values that I'm talking about when I say from here to here? I'm talking about negative 1 to 0.4, decreasing. Okay. So negative 1 to 0.4. And we should put a union symbol in between these two just to show that both of these together are the decreasing intervals. But our journey's not over, so let's get back to the graph. That's not supposed to draw, that's supposed to drag. Alright, looks like we have one part of the journey left. One last increasing interval as we go up, 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 and forever. Okay, but it's not the up part that we really care about. It's the x value. So this increasing interval starts here at an x value of 0.4 and it goes to the right forever. So we're going to say 0.4 to infinity. Okay, not because it's going up, but because it's going to the right forever. So 0.4 to infinity and beyond. Quick, can you name what movie that's from? To Infinity and Beyond. If you said Toy Story, you win the prize. Okay, so we're picking up from 0.4 and we're going to infinity. Okay, and don't forget the little union symbol to show that both of these together are the increasing intervals. Okay, 30 minutes. This was a long video. Did not see any way around it. But I hope it was helpful to you guys. And that's the end of this lesson. I will see you on the next video, you guys.